All right, this is 6.2, part B. So this is the second part of this lesson. If you haven't watched part A, go back and watch part A of trig functions. So here we have other trig identities. So some of them you may, these may be brand new to you. So here we have tangent. The definition of tangent is sine over cosine. And some of you might say, well, I thought tangent was opposite over adjacent. Well, it is on a right triangle, but in general, if you take the sine divided by the cosine, that will give you the tangent. And then cotangent would obviously be cosine over sine. Now, these other three trig functions, trig identities, you need to be familiar with, especially this one right here. This one comes into play all of the time. So sine squared theta plus cosine squared theta equals 1. That's a fact. You just need to use it a lot. These other ones you will use from time to time. Just be familiar with them to make sure that you understand what they are. So let's look at a way to use these trig identities. So using trig identities, find all 5 trig functions if sine of theta is 0.6. Now, there's a couple ways to do this. Like there's 3 ways I can think of right off the top of my head that I can do this problem. But they ask us to use trig identities to do this. So, there are multiple ways to do this, but to use trig identities, come down to this. This is a trig identity. So sine squared plus cosine squared equals 1. And we know sine of theta is 0.6. So 0.6 squared is 0.36. And then you're going to basically solve for cosine of theta is 0.8. So this is 0.8, and we already know this is 0.6. Well, remember, tangent is nothing but sine over cosine, and cotangent is cosine over sine. And then remember, cosecant is 1 over sine, and secant is 1 over cosine. So just knowing these two, you should be able to find the tangent, the cosecant, the secant, and the cotangent after you found that. So again, that's how you use trig identities. I'm going to leave the calculations up to you. Again, all that answer. All right. So this next side is probably brand new. You're going to use trig identities. Think of all the trig identities that we've done so far. And we're going to prove the left side equals the right side. Now, one caution to you is I'm not solving an equation. I'm literally showing the left side equals the right side. You did this back in geometry with proofs. And you're basically, again, don't do, what you do to one side of the equation, do the other. That's solving an equation. Don't do that. You're just working on the left side, proving that it equals the right side. So if you look at this next one, or this first one, we'll start off kind of easy. Well, tangent of theta, I already know it's just tangent. But cotangent, remember, is 1 over tangent. And when I multiply these, you can see that the tangents cross out, and I'm left with 1. So 1 does equal 1. So you're proving that the left side equals the right side. So once you get down to this step, the left side does equal the right side, and you've shown the work how it does, you've proven the left side equals the right side. So let's come down to the next one. Well, again, typically sine and cosine is what you want to leave alone. So cotangent, you guys know the definition is cosine over sine. And here the sines cross out, and you're left with cosine. And again, cosine is what we're trying to prove. Check mark. Very similar. You have sine over cosine times cosine. The cosines cross out, and what's left is the sine. You're proving the left side equals the right side. Now, let's pick it up a little bit more difficult. Now, one of the other identities I told you to make sure you know is sine squared plus cosine squared equals 1. That fact you're going to use, okay? Now, what we're going to do, again, don't just focus on taking the left side and showing that this equals 2 sine squared theta minus 1. Well, what I'm going to do, since I'm trying to change it to sine, keep in mind I'm trying to change it to sine, so I want to keep sine here. So I'm going to basically solve for this cosine, I'm going to make a substitution here. So I'm going to basically subtract sine from both sides. And so cosine squared actually means 1 minus sine squared. So that is what I'm going to substitute in right there. So I'm going to substitute that for that. So we're going to keep this sine squared theta minus 1 minus sine squared. Sine squared, use the distributive property. I'm going to combine my sine squared and sine squared. That's 2 sine squared. And notice it equals the right side, just by using my trig identities and substitution. All right, this one right here. So sine divided by cosine plus cosine divided by sine, that is supposed to equal cosecant. Secant, well, how in the world is it supposed to do that? Well, sometimes you got to step back and think about it like, well, what do I have? I have a fraction plus a fraction. So think of like 2/5 plus 1/3. Well, how do I add fractions? I got to get a common denominator. Well, my common denominator between cosine and sine is cosine sine. So I'm going to literally change this to cosine sine. Cosine sine. And just to save a little bit of time, you know, these are all thetas, right? So just to save time, sometimes I forget to write the theta until I get to the final answer. But they all have thetas with them. Okay, so you still have the sine up top and cosine. But notice what I multiplied by. I multiplied by sine. Here I multiplied by cosine. So I'm going to end up getting sine squared theta plus cosine squared theta. Now combining those fractions to be cosine sine. So far I basically just got a common denominator and I added them. But notice that right there. That's one of the trig identities. That actually equals 1. So that's 1 over cosine sine. All I did was substitute that for 1. And that right there is 1 over cosine times 1 over sine, which is secant times cosecant. And that the left side equals the right side. Now, let's look at some definitions that you may have seen before back in geometry. You have an observer and you have the angle of elevation. You're looking up to an airplane, looking up to the top of the tree, you know, top of the mountain. So that's the angle of elevation. And then you have the angle of depression. So you're looking down the hill or down from an airplane or something like that. That's the angle of depression. So let's look at a word problem here. I've drawn a wonderful looking picture, and you have a person looking to the top of the building. And you have the angle of elevation is 78.3 degrees. That's how high, the angle that he's looking up to get to the top of the building. You also notice that he's standing 115 feet away from the building. And I want to know how tall. I want to know how tall that building is. So you have to, this is my theta, like my reference angle, and it's 78.3 degrees. So think of what trig function would I use that involves the opposite of the angle and the adjacent. Well, opposite over adjacent is tangent. So tangent of 78.3 degrees is opposite over adjacent. And then, of course, we're going to solve that. So x equals 115 times the tangent of 78.3 degrees. And then you just plug that into your calculator, and that would give you your answer. Make sure, again, you're in degree mode when you plug that into your calculator, because we're talking about the tangent of 78.3 degrees. And then you would get your how tall the building is. And always pay attention to the direction. The directions say may round to the nearest foot. It may say round to the nearest tenth. You know, whatever the directions may say on the question. And then finally, this says find A and C. So here you have a triangle. It's a right triangle. And notice I have 18.4 degrees on this. And I'm going to find A and C on this. Well, notice what we do know. We know here's the angle. So we're going to do some trig function of 18.4 degrees. And we need to find A and C. So we do know the opposite of that, and we need to find the A and the C. So it does not make a difference which one you want to do first. Let's go ahead and find A. So if we wanted to find A, that means we're going to do opposite over adjacent. So that would be 4 over A, and that is the tangent function. And that would find us A. Now, to actually solve for A, actually, before I solve it, let me go ahead and set up the other one. So I'm going to have blank of 18.4 degrees, and I would use to find C, opposite over hypotenuse. That would be the sine of 4 over C. The sine of 18.4 degrees equals 4 over C. So to solve this, you're going to multiply by A. And so here you have A tan of 18.4 equals 4. And then to solve it, we're going to divide by tan of 18.4. And then you just plug that into your calculator, again, in degree mode, and that's going to give you the distance of A. And same, likewise here, you're going to multiply by C. That's going to give us C sine of 18.4 equals 4. And then just divide by 18.4. And again, follow the directions. If it says round to the nearest tens place, hundreds place. So typically, you round to the nearest tens or hundreds place. So you follow directions, whatever it is. But again, I'm saving the calculations for you. You just have to do the calculations in degree mode and then be able to get the measurements of angle or side A and side C.